This is the ROS Developers Podcast, episode 118.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the ROS developers that are ROS developers. So if you are a ROS developer, if you are creating programs with ROS, then this episode is dedicated to you. Why? Because today we are going to learn more about how to develop in a better way, in an easier way, in a faster way. So if you are a ROS developer, this episode is interesting for you. But before going into that, let me tell you that if maybe you are a beginner ROS developer, or maybe you are a proficient also ROS developer, you may need to learn some new stuff about ROS or to remember some stuff that you already knew but now you forgot. Then the best place is, of course, The Construct. At our online academy, you can learn about many different subjects, all of them related to program robots with our favorite framework. So you can learn about ROS 1, ROS 2, and many combinations by using those frameworks in order to program your robot. And you will learn it by using a special method that we have created, which is based on simulated robots that we have in the cloud. So you don't have to install anything. Just go open the course, the simulation will appear and the lessons, and you will be practicing from minute number 1. Everything is based on practice. And as you progress, you will be able to connect to our real robots, not only simulations, but real robots that we have here in Barcelona in our offices. Is over there, let me see. Yeah, there, behind the sign of The Construct, there is a door, and then you can access to the robots. Okay, just joking, that's not right. But the robots, they are real. They are here in Barcelona. And you will connect remotely to those robots and then practice also with them. So it's a complete academy for learning ROS and programming robots. I will put a link to the show notes below here on the video. And well, so that's the moment that we have to go to the meat of this episode. And then in this case, let me introduce you, Limor Schweitzer. And Limor is the CTO and founder of MOV.AI, a company with the goal to create infrastructure software for modern automation. His company has recently released the community edition of MOV.AI Flow, and that's one of the main subjects that we are going to talk here with him today. Welcome to the podcast, Limor.
Thank you, Ricardo. It's a pleasure.
Yes, it's a pleasure. We met in a ROSCon the first time, in face-to-face. I mean, the ROSCon in Macau, pre-pandemic. The first one, the last one, pre-pandemic.
Yes, that was fun. Probably at the ROSCon before, but that was memorable. The pre-pandemic ROSCon in Macau. I ended up spending there 2 weeks because we had also an installation there. And it was a fun event, followed of course by ROS.
Yes, exactly. Yeah. But I didn't see you this time in Tokyo, on the last one. Were you there?
Yeah, I didn't make it this time.
Okay.
But hopefully this year.
This year. Yeah. Okay. Great. And since then, so many things have happened since the last time we met. And but before going into that, I would like to explain us to the audience. So how is that you started MOV.AI? So how did you start it and why?
Okay, so let me start by giving a bit of background about my glorious past. Um, so I got into Unix. Remember that thing that before Linux there was Unix?
Yes.
Many years ago. So I had the opportunity to work in one of the first Unix installation in Israel. I was living in Israel at the time, and we had an installation on a VAX. Somebody installed the Berkeley the Unix, and I got access to it as a kid. And I learned, I grew up there basically with knowledge of this Unix that then became commercially transferable skill. And I did the army in Israel in the intelligence and was a programmer. And then I went to university and studied physics, but I built a business around Unix. Everybody suddenly back in the 90s wanted this Unix thing. You know, suddenly the killer app was email and Usenet, and so I had a business, a consulting business. We reached up to 200 people that were installing Unix and what's called today DevOps. Back then it was system administration. So that's kind of my background. It's coding, algorithm, and deep Linux kernel and networking from very early age. So I had a company then that went to Silicon Valley, and then after that I decided to get into robotics. So we're talking about 2004, and robotics seemed to be like the next big thing. It still is the next big thing. And so I set up a company where, first of all, I tried to get some venture capital money, and after in the Silicon Valley company with the software for telecommunication, we raised tons of money, like 80 million. I thought it wouldn't be a problem to get some money to develop toy robots that would fight each other, humanoid robots, but I couldn't get any venture capital for that. They told me they don't do flying cars, time machines, and robots at the time. So then I decided, okay, I'm going to do this myself and set up this e-commerce business to support the R&D, and things evolved and took a life on their own, and the e-commerce business. And eventually I had a lab, and we did all kind of fancy robots, but one-off. Like we worked with National Geographics in a robot that was in Africa. We did stage events, dancing robots, camera robots, a lot of fun. And then around 2015, 16, we started working in industrial. We developed a robot that was pulling carts called Tugbot. This is one of my companies now. And the Tugbot was specialized in pulling industrial carts. And throughout this period, from 2004-5 until 2015, ROS emerged as the leader. It was not the only pub/sub framework. There were others at the time. Even Microsoft had its go at it. But ROS was kind of the clear winner with the Willow Garage, which turned into OSRF. And it was a wonderful system to develop robots. So one-off robots was perfect with ROS. It was like, without it would be much more complicated to do things with humanoid robots, with all these sophisticated SLAM and things that were out of reach if you wanted to develop from scratch. Yeah. But then what I realized was that with these industrial projects that I was getting into, that ROS was not perfect, that it lacked some functionality that I would say that wasn't available. It wasn't in the mindset of the people that developed ROS. It was more relating to the personas and the people involved in dealing with these autonomous robots and robotic arms and cobots. So I got some venture capital money back in 2016 with the idea of developing a framework which would support different kinds of autonomous robots. And as a reference design, we used Tugbot, this robot that was deployed, and I spent a month analyzing the ROS code, and I wrote this monumental document about all the stuff that is missing, like 15 things, core features that were kind of missing in order to transform ROS into something that would be viable in a commercial deployment of fleets of robots.
Is this document available online?
No, it's an internal document.
Okay.
But maybe I'll put it at some point. But it's it was really. I think it's still valid. Everything there is still really valid. Like, for example, the how you define graphically, how do you visualize the publish, subscribe, and the nodes. Like, if I wanted visual representation of the nodes and the connectivity and the dependencies between them, and things like containerizing processes for cybersecurity reasons and for ease of deployment, kind of an app store framework for deployment. At the time, there was no Docker, so containers was evolving, but the process isolation. And so these things, among other things, were missing. And so that was the scope of the startup, to create this commercial framework that had the ability to support different kinds of autonomous robots and cobots in order to be able to do these complicated developments, especially in light of modern, what I would call modern automation, is automation that kind of mixes machines with people. So in the traditional automation, there is clear separation. There are safety cages and laser curtains and all kind of regulation to protect people from machines. In modern automation, which started with ROS, first it was really academic. To get PR2 to go to the fridge and pick out beer and bring beer. So the idea of working among these powerful robots was a novel concept and didn't really have initially real applications because automation didn't really need this kind of mixing of people with robots. But eventually, kind of a chicken and egg, it emerged. Universal Robots and Mir and others came along and Locus and created use cases for putting people and robots together. And that's it's like what Spider-Man said, with great power comes great responsibility. So you need to have intelligent robots in order to deal with silliness of people.
Okay, now I see the metaphor. Okay.
So that's kind of the background. So in 2016 we raised the first seed funding, and then we got some more proper venture capital.
But which goal? Which goal? Yeah.
Well, to develop, to build a team and to develop this platform, and then to license it to the developers of commercial AMRs and cobots. So the success of Mir and others led to a lot of AMRs to emerge. So AGVs have been around for 30 years. So line followers and magnet followers, they've been around for a long time. And the autonomous robots indoors were a relatively new thing, and everybody was developing their own stuff. Typically, they would take ROS and build some user interface around it and use the AMCL and do, until today, a lot of people, this is what they do. And sort of navigation 1, or those, the avant-garde ones use navigation 2 now, but it's, but that was around about it. The thing is that it gets more complicated. As you start deploying, you discover that AMCL, those frameworks of SLAM from 15, 20 years ago are not robust enough to deal with real chaos and that you find in fulfillment centers and production lines and industrial environments, bad Wi-Fi, a lot of technical problems in real life deployment of fleets of robots.
But is a problem of the robots themselves, or is a problem? Of the hardware, or is a problem of the software?
So I think there's two things. So this technology is new. So people typically they will buy an AMR and expect that it's like a Volkswagen car, and it isn't. It's new technology, and stabilizing the technology takes time. In that sense, China is winning that battle because they just have very quick development iteration, huge internal tolerating clients and client base. So because it takes a lot of iteration to stabilize the hardware.
Yeah.
And so, but that's, let's say it depends on who is the team and how it's done. But then the software itself also, it's very sophisticated in terms of like the going from lab to 24/7. You discover a lot of details that are unexpected, and so that's experience.
Yes. Okay. Yeah, I know what you say about going from lab to 24/7. In our case, we are also providing to our students, as I mentioned at the beginning of the episode, the access to the robot, and we have a warehouse robot, and we have a cafeteria. So, and those are 24/7 running because anybody can get into there, and it's crazy. So if you explain, I'm doing this kind of lab, and everybody will say, oh yeah, well, that's already solved. No, yeah, it's already solved to work for half an hour there, and then you switch it off. But if you leave it there, running, actually being used by different people at different times, and so that's a lot of work still to be done.
Exactly. So the AMRs, I mean, it's been now 10 years, let's say. So there is maturity, especially what I've seen is a cost reduction exercise on the sensors and the lidars. Now the 16-line lidar is available, Chinese at $1,000, and Velodyne and Oster have now merged, and you can squeeze them to something decent. So it's the sensor side of things that there is a cost reduction exercise. There is still, I would say, the clients, the industrial clients, are not super sensitive yet to price in that sense. It's not like super competitive that your margins shrink, but it is. It's getting there. Eventually, on certain form factors of AMRs, there's going to be a price squeeze, and because a lot of these rectangular little things that move around there's very little differentiation, and so but the growth is still not huge. But I've seen deployments of thousands of robots, and so then every little detail in the hardware counts, and the cost counts, and so we're getting there. We are in a scaling stage of this AMR. I think COVID made a big push to the industrial operators to want to quote unquote get rid of people. A lot of what I see, especially in Europe, is that the workers in these operations are temps, so that it's not a permanent job, and so they're competing with Uber and with
any other temporal job available.
Exactly, and so the job of pushing carts or moving stuff around, or sortation or insertion and supermarket fulfillment is. And working in minus 19 degrees and all kind of stuff. It's not always competitive with sitting in a car and driving Uber. So that's one consideration of many, that the automation is happening regardless of the economy, regardless of everything. It's kind of it's imminent, and so we are seeing a growth on the AMR. I mean, the AMR is a relatively small subsegment, but it is growing very much.
One thing, I can think like I can hear. Sorry, I was hearing kind of a noise like a pack. Is anything on your side about this? No?
I could be. Is it better now?
Yes. Now it's better.
Okay. So
Yeah.
do you want me to repeat?
No.
something?
It's okay. It's just that it was doing on a periodically noise.
I think I was playing with the headset here.
Maybe it's that. Maybe that was that noise. Yeah, exactly. So for the audience, that when they are on the headphones, that sometimes is annoying.
Yeah.
Okay,
but you're going to cut this out, right? So.
Yes, we can cut this out. Yes,
Right.
okay. Yeah, no problem. This discussion, you mean? Yes.
This last 30 seconds.
Yeah. No problem. Okay. No problem. We cut up to here.
Okay.
And then, so how would you describe the role of your company in the current robot space?
Yeah, so we deal with fulfillment centers with food and apparel and manufacturing. So our role is, first of all, is kind of educating the market on different levels. So we've been doing it now for a few years. So first of all, there is the separation of hardware and software. So that's not obvious, because in the industrial world, typically, if you think of a refrigerator, you don't think of software upgrades or recurring revenue. Okay, do you pay per egg refrigerated? Doesn't make, like, imagine the refrigerator vendor would say, "Oh, you pay per egg that is refrigerated in the refrigerator." It doesn't make sense. So
don't give ideas. Those kind of ideas here. I'm going to cut this from the podcast also. No way. You're joking, just joking.
So I think it's so there is the education aspect of it, that when we started, it was not obvious to ask for recurring revenue. So I'm going to touch that point in a bit. Mm-hmm. And the other thing is also the producers of the AMRs and the cobots. Actually, in the cobot space, the separation is quite obvious from day one because of historical reasons. It's always been, you had the end effector, you had the producer of the robot, and then you had producer of the robot gave some software, but there was always third-party software, and there were kind of access to the APIs and to the way of controlling the robots, the robotic arms. Mm-hmm. So in the cobot, when the cobot emerged, it was the same. I'm tracking now 65 software companies for cobots. So pretty amazing, and they raised tons of money, like billion tons of money.
Wow.
In the AMR space. Again, the typical, historically, the manufacturer would make the software as well. And it led to several side effects, because if you're not charging for recurring license fees, then you don't have money to keep your engineering team. And therefore your software kind of stays fixed, and it's not a profit center in your organization. Now, venture capital, Silicon Valley venture capital demands, like, there is only one business model in the world, and it's called SaaS. That's it, mm-hmm. Software as a service. Mm. That is it. The entire venture capital world is obsessed with this model. In my history, before there was cloud, there are other business models, but they were dumped for various reasons. But now, so Silicon Valley invented this thing of ARR. So your valuation is a multiple of your recurring revenue. Now, when you sell hardware, it doesn't make sense, but it doesn't mean that you cannot tell a good story. So the recurring element in companies that don't charge for a recurring license, then obviously they don't have money to pay the engineers to upkeep the software, etc. So you can see that in the old AMRs, like, okay, I won't mention names. But
you can if you want, okay? So feel free.
Yeah, but in the let's say in the last few years since we've been around, then we were pushing for this agenda that says there is a reason to pay us a license fee even 3 years from now, because you need cybersecurity updates. There are improvement of the algorithms. whenever you touch your fulfillment center, you change things. It's not stationary. It's not like a Volkswagen production pipeline. So you're not making now 200,000 cars. You're doing some fulfillment and things change. Yeah. And therefore the software needs update, and every time you interact with software, you expect it to be up to date. So that's one thing. So the recurring revenue model, and a justification for a recurring revenue model, which is chicken and egg with the venture capital money. Venture capital demands recurring revenue. And so there is a part of that we had to kind of educate the market that there is this thing. And you heard of robot as a service. And so all these things are around venture capital. And then educate the manufacturers to say, well, yes, you can put 3 kids in a room and they will put together something cool with ROS, but it's not going to cut the mustard when you scale and when you've got hundreds of robots out there, and it becomes a big problem. So that's, I think, so in terms of our role in the robotic space, that's one thing is we kind of brought these concepts into the market. And the other parts of it is so reconfiguration, cybersecurity. So cybersecurity is another thing. When you go today to most of industrial areas, there is no notion of cybersecurity because the theory is that if you don't connect to the internet, it's okay. Mm-hmm. And that's going to change. So I remember at the beginning of the antivirus world, there was an effort, like they would pay kids to hack to do viruses. It was misdemeanor, I would say. It wasn't like today, the guys who hack for money, and then they have call centers that explain to you how to sign up to Bitcoin to pay them. But right now there is going to be, now with the Biden program of separating, or kind of more of a disconnection from Russia, China, and so there is going to be much more awareness and probably regulation around cybersecurity. And so the updates of every HP laser printer, every stamping machine, every pendule that is running Linux with a kernel version 4.13 will suddenly be a cybersecurity hazard for the entire factory, and that will matter. So that's something that will probably work in favor of this kind of separation of hardware and software and justification for updates and recurring revenue. I see. So that's it. So I call our fleets data centers on wheels. It is very much the same but more complicated, right? A computer in a data center has a fast communication bus. It doesn't have a keyboard, doesn't have a monitor. That's it. Just has Ethernet. Uh-huh. A robot in a factory may have 30 different peripherals, but it's still the same computer, and it still needs to communicate over wireless networks. Uh-huh. So I made a long story out of your question, but hopefully I
it's okay, because it's clarifying in some aspects about the current state of robotics in one specific sector, the one of the AMRs. And also you have exposed all those problems about the risks that we have in the future, especially about cybersecurity, and which ones are the business models that have some future and the reasons why. So yes, that was very, very clarifying. And so then you have explained all this about the beginnings of your company and also your role, but which one are the main products of your company?
Right. So we have basically one big product. It's a framework. Mm-hmm. We call Flow, and the framework has a community edition, which is a source available. Mm-hmm. I would call it open source, but probably the lawyers would say not to call it open source, but to
Why
call
not?
it source available. Sorry?
Why not open source?
It is open source. It's just that open source typically relates to licenses like BSD, MIT, GPL. Our license is kind of custom. It's very simple. It's like 2 paragraphs, but we just don't want the software to be sold using the same business model that we do. So you can use. So if you want to use our software to develop your own, if you're an AMR manufacturer and you don't want to work with us and you want to develop your own
Solution.
Software, that's fine. But we don't want somebody to compete exactly as we do, like to put it in a let's say to put it in a cloud and sell it, or to sell it just the same and mimic the same business model that we have, which is to sell licenses based on this with additional. So there are the specific cases that or a couple of cases that we thought would be annoying from experience from other open source companies. So we adopted that framework. You can read the open source license. It's the term is source available, meaning it's open source, but it's not kind of a standard.
It doesn't give you all the rights. So you can see the code, you can compile it, you can launch it, you can use it, but doesn't give you all the rights.
Yeah, I mean, it gives you most of the useful cases are there. Meaning, if you don't want to work with us, but you want to use our software, if you're an AMR manufacturer or a cobot manufacturer, you want to work with this software, fine. That's fine. And we see that as the more people work with our software,
expanding.
That's the reason why to do it open source, because if more people work with it, it helps in debugging the software, it helps in promoting the brand. There are specific cases where, like Amazon is known to do stuff with cloud open source software that was annoying the
original creator
to the code.
I see. Okay. Yeah, but you still didn't tell us what is MOV.AI Flow, which is your product. What is it?
Okay. So what is Flow? So the idea of Flow is three main topics. One is it's a file. It's a single file that defines the ecosystem of nodes that are going to be running over time. So unlike ROS, there is a concept in Flow, which is that different processes may be needed at different times. For example, when the AMR is in a 400-meter corridor, maybe it doesn't need to run the 3D SLAM, which consumes 4 cores and then 3 amps. Maybe it's better to kill the SLAM for a bit in the corridor, because you don't really care where the robot is in the corridor as long as it reaches the other end of the corridor. Something like that. So then it's battery efficiency and whatnot to kill the process when it's not needed. So the idea is, so that's one element in the flow that you can define. We call it a state. The state it's kind of a state machine, but the idea of a state, it's actually a running node that is subscribed or is listening to, is connected to, sort of for the state answers the question, what is the robot doing right now? So the robot is right now, let's say, aligning for charging or entering the corridor or, picking the box. So it answers that question. That's the state in the flow, in the MOV.AI flow. And the state also defines what is necessary to run in order for that state to exist. So when you are aligning with the QR code, you need the April tag detector, right? And you need, and as a byproduct, you also need the camera driver to be running, and you need, other localization needs to be running, etc. When you're doing something else like entering into an elevator, then when you're in the elevator, you can disable the April tag detector. You
navigation.
can disable the SLAM.
You don't need navigation.
Right. So the state answers what are you doing plus what do you need.
Okay.
And so in MOV.AI, the advantage is that it's really easy to do that. So you can create arbitrary complicated setups with encouraging multiple nodes and complexity because it's all visual. So how do you work with that with Flow? So you've got it's a visual representation of a typical pub/sub environment in ROS
with blocks, right? It's like a block that you can drag and drop.
Yes. So if we take a typical Navigation 1 ecosystem of nodes, you've got the
map server.
EKF. Okay, so let's say you start with a blank canvas on MOV.AI on Flow, and you drag the EKF onto the canvas, and then you drag AMCL, and you drag move base, and then the camera driver, and tab local planner, and then you connect all the wires. So there's like inputs on the left and outputs on the right. They represent pub/sub. You can also do service and action, but let's say in terms of pub/sub, then you can only connect, let's say, pose width covariance can only connect to a pose width covariance.
Yeah, the same type of message, right?
The type of message and protocol. So it doesn't allow you to connect arbitrary anything to anything. And this is, so it gamifies it in a way. It makes it super easy to do this kind of. If you try to do that with ROS launch, it's a big project.
It's complicated, and sometimes it doesn't have the effects expected because some nodes run faster than others, so they are waiting for something that is still not.
Exactly. So you've got all kinds of. So here it's really easy. So the other aspect of the flow is that the parameters to the nodes are in user interface. So you can give the parameters, I don't know, the coefficient or whatever it is that you want to pass. You can give that in the through parameter server. I mean, there's no real need for parameter server. I never understood why it exists, but you give it. It's through user interface and it's passed in the command line or through the parameter server. We're talking ROS 1. In ROS 2, there is no parameter server, but you pass. It's very similar. The format of the pass. Of static parameters. But we support all of the features of ROS: dynamic, reconfigure, DLLs, meaning nodelets. Everything is supported, so you don't lose anything, any feature of ROS by using MOV.AI in a flow, and it's all presented. So, for example, if we take April tag detector, which is a nodelet, typically a parasite of the camera node, right? In MOV.AI, you'll see two blocks, and they'll have like an orange line connecting through a port, which is defined as a nodelet. So it's clear that this is a parasite of that.
Okay.
So everything is easy. So it takes away the complexity that you have from setting up the node ecosystem. Then you've got this state machine or state transition. So you're going from corridor to room to charging. And so you define these blocks that are state blocks, and then you say what they depend on. Everything is very visual. So any modification is cheap. It's like what I've seen many times is people set up these super complicated ROS launch files, and then they kind of it's too complicated to change, so they keep it like that. So processes keep running forever, whether you need to or not. Because it's just the cost of change and the hassle of regression testing is too much. With our system, it's like super easy. So you focus on other stuff and not this. This is not where you get stuck. We have really, really complicated setup in terms of the launching. So it defines also the left to right on the flow defines the timeline. So
what does it mean, the timeline?
So it means that you go from state to state, left to right. You don't have to, but it just shows you what is the robot doing now. And when there is the editing mode and there is the runtime mode. In the runtime mode, you see things blinking and they tell you what nodes are currently running.
Okay, so that would be, for example, in in a debugging situation, right? So you build your programming flow, but then there are bugs, like in every code that we do, and then you run it inside the flow environment itself, and then it's running, so you can see what is happening with the different connections with blocks are activated, running at that moment, and
So you see what processes are running. And another feature of Flow of the system is that we have a in-browser VS Code editor for Python. Now, it's not a ROS node editor in the sense that it's coexist with the user interface. So
I see.
You double click on the block. We have these things called move nodes. So they are so let's say EKF will have fixed predefined inputs, outputs, and parameters, right?
Mm-hmm.
But or AMCL or nav2, but the you can do DIY a node. They're called move nodes, and then you can add an input port of type ROS1 service, or you can add an output port of ROS2 publish. With a caveat, right now ROS2 is still under testing, so it's not available in the community edition yet. But that's the idea. We support HTTP. You can create essentially a web server that has on the same node runs a web server and a ROS publisher.
Oh wow! And then sorry, go ahead.
So the common denominator between all these protocols, so you can do, I don't know, other protocols, OPC UA, MQTT, whatever, as long as the message is fixed, which is the paradigm of ROS. It's fixed messages. So in ROS it was quite clever that it's really hardcore fixed messages. You have to compile the message in a way, and all these tricks of the ROS serial and others were really a hack. Like you look at the code, it's crazy to bypass this restriction, which is good. So it just means that you have fixed messages. So even HTTP, if you look at a web server, there are fixed messages in a way. So the protocol is arbitrary. You define the protocol outside in the user interface. You define what is the protocol on the input port that you want to listen to. And then when a message, you connect from another block to that input port. And then once you receive a message, your callback in Python is called. The callback is a Python callback. So your code is net callbacks. You don't deal with the preamble of setting up ROS or setting up a server, a publisher or spinning. You don't do that. You only deal with the callbacks. And it's a kind of a walled garden that protects the programmers from themselves.
Well, and also saves a lot of work also. It's a nasty work because it's doing all those things all the time, every time. And you mentioned that it has to be done in Python?
Right now we are doing it in Python. Initially when I started it, I prototyped it in C++, but because of the nature of how messages were compiled, essentially, it was really difficult to do this exercise in C++. So I dropped. So in Python, there is no reason not to use Python. I think most of the algorithmic or mathematical stuff is anyway done in C++, and then compiled, and Python is a wrapper, and you've got Cython. We still don't support sort of the compiled Python, but essentially the role of the move node is not to, right now, it's not a replacement for writing a new algorithm. It's more of a glue code to deal with message transformation or with state, or with, for example, the robot has to go to that position, scan the area, look for available pallets, then go through a 4-stage motion towards the pallet, making sure it's not a baby, right? Mm-hmm. That stuff in Flow, it looks beautiful. Like it's really, you can look at it and say, I understand what its thing is doing. Just
by watching the set of blocks and the connections between them. Right? Yes. But then, let's imagine I'm using this IDE, And then I create my blocks connect, I run it, and this is somehow connected because it's publishing on topics. So on my computer, I have access to the topics of the robot. So the robot is executing, right? But the program is being executed right now inside Flow. So how do you transfer into a robot?
Okay, so we in ROS you would run, ROS launch, and it would read the XML file and then run the nodes.
Exactly.
In MOV.AI you have this thing we call a spawner, or it's like a launcher that keeps it's the parent of all the nodes, and it runs nodes as needed, and there is so it's a scheduler. It's a process that runs and kills, and we plan to do to support full ROS2 lifecycle within that framework.
Yeah, that would be better because then you don't have to kill. You can pause.
You don't
them.
always have to kill. Exactly.
Yeah.
So that's one of the features of ROS2. But since we've been working since before ROS2, in ROS1, it's just, starting and killing the process. You can also send, in theory, a SIGSASP or something and freeze it and resuscitate it. But typically it's not needed. They're okay. But so the spawner is in charge of the processes. It's the parent of the process. In case of now containerized processes, it's still running. It's Dockerized. So the spawner still has a role in launching containerized processes.
Okay. So but then that has to be installed in the robot, inside the robot, right?
Well, Docker has to be installed, and you have to download the images of the relevant. So every node, so this is in the next release, but every node runs in its own container, meaning that you can have, it's like an app store. So you download AMCL image, Docker image, and it comes, it's layered. So it's built on top of, Ubuntu 18, and then on top of that you have ROS core, and then on top of that you add AMCL. So you download that, and then use Docker tools to download it, or MOV.AI will do it for you. We'll use the Docker to execute the Docker API to do that, and so it will run eventually AMCL Dockerized. So it's like a binary distribution for nodes, for individual nodes. So if you've got a new, April tag detector or SLAM, today the way you distribute the software, you upload it to GitHub and then give an encyclopedia of instructions of how to compile it, and results may vary. In a Dockerized or a containerized world, you have that, but in parallel you can also provide that as a Docker image and say, run that executable.
Yeah.
In the end, the Docker is an illusion, so it's a process. So you have to run. There's no inside and outside a container. I mean, I come from a world where this didn't exist. There are 200 features in the kernel for process isolation. There used to be 5 back in the days. So Docker and Snaps and LXCs, and so they exploit those process isolation features, which help in different things, from cybersecurity issues to distribution of binaries without fear of disrupting the external operating system. So the spawner will now run AMCL in a single container, but it's a process. It's just isolated. So you don't need to install ROS with MOV.AI. It's just everything comes containerized.
Okay, and that's so that the spawner and all the nodes related to the application is the result of the MOV.AI Flow program that they have created, right? And this is kind of it's just a set of Dockers that are pushed somewhere, and then I have to pull them in the machine that I want to run them.
Yeah, there are scripts, of course, to download them. At the moment, the Community Edition currently, it's a fixed set of Docker images that run with the Ignition simulator. It's more there's going to be new versions that have more of this feature. Currently, you just run a couple of scripts and it does everything for you, and it pulls the the images, and you run, and it runs in a simulated environment. It's a kind of a taster of MOV.AI, I would say right now, because it's linked with a simulator. If you want to run it on a proper robot, you can. There are instructions, but you have to work for it. If you just do next, it will run ignition, and while you can see a warehouse with robots and see the flow and understand how it works. So that's So I don't know if I made myself clear.
Exactly. So now at present, let's say the automatic thing built inside Flow is the one that allows you to execute your code and also see the results on a simulator on Gazebo ignition. In this case,
ignition,
right?
Yes.
And then just to clarify, to see if I have understood correctly, right? Then if you want to use this program that you have created inside Flow in your own robot, still you can do it, but it's not as easy as pressing play and then with the simulation running. So you have to do some steps that require knowledge. Is that right?
Yeah, because the drivers in a simulator, we can control the experience.
Provided,
right? It's a simulated camera driver and a simulated odometry driver. With a real robot, I don't know what odometry you have. I don't know what camera you have or what LiDAR you have or what else. So that's where, but it is, we did integration projects with new robots, and the first iteration takes a few days, and it's not a lot of work. Then of course you need to work, because you need to think differently about how you operate the robot differently than standard ROS. You have a lot more power to do things, to create maneuvers, and so it's so currently it's very similar to what you have in the construct. I mean, you have a headless simulator streaming, and you've got a ROS environment that links with the simulated sensors. So
exactly.
Similarly,
in our case,
it runs. You need to run it on an NVIDIA computer. It's ignition.
For the simulator.
So.
Other
aspects of Flow, we are in the API that you get in your callbacks. So we give you can import TensorFlow and OpenCV and do whatever you want. We give a class or libraries for dealing with internal stuff to MOV.AI. For example, we like Redis, so states shared stuff between nodes. We use Redis, so Redis runs in the background, and you can communicate between nodes, between move nodes using Redis. So we have an overlay on top of Redis for inter-node communication. We have other things like the format of all the class libraries that define the notion of node. So a node is not the binary node, but the metadata that represents the EKF with all its inputs and outputs and parameters. You have a class to read if you want to scan through that data or generate data or add stuff to your node so that it gets represented nicely. You have an API to do that as well.
Okay.
So we provide that. We use it. We've been using it for our fleet management. So a lot of our fleet management features are not in the open source, but some of them are.
Fleet? You mean fleet management software?
Yeah. So when our commercial offering deals with fleets. So how do robots? What do robots need to communicate between each other and between manager to affect a fleet? The Flow deals with a single robot. It doesn't deal. You don't have a view in the Flow of the fleet. It deals with a single robot. Of course, there are in the Flow you can define communication layers that deal with outside of the Flow, or for example, if you've got 3 computers on your robot, you can also, there are tricks of how to show them in a single flow. But the idea is a single computational element, a single robot. A flow is what runs on a single robot. In our commercial offering, we have the notion of a fleet. So the robot wakes up, signs up to a fleet, and there are things that he needs to communicate for several reasons. For example, in the fleet manager, you can see where the robots are. So each robot needs to communicate where he is every few seconds. In that fleet management, you have things like global mutex, or things, lockable areas for doing a separation, space separation. So that those mutex areas, I think that is in the community edition in the API. But that's an element of fleet, because if you need mutex area is kind of the standard way of dealing with shared space. So that when you penetrate into mutex, that you cannot
go into that direction, for example. Because
you cannot go there because somebody else is there. Space.
Exactly.
Yeah.
In a physical sense, because we are used to talk about mutex in the computer programming sense, but now it's a mutex for not going into an area, right?
Yeah, exactly. So it's a digital representation of physical space.
Of a physical space, exactly.
The Industry 4.0 thing. So we have those elements of fleet, like centralized logging and all these things. So those are part of our commercial offering. A lot of them. I'm not sure right now what is in the community edition and what is not, but the idea was that we have unique algorithms. For example, we've developed this very elaborate 3D SLAM, very robust. We developed very complicated calibration calibration meaning deviation from the CAD model of the robot. So it does simultaneously laser, camera, and other sensors to identify the deviation from the CAD model.
The position of those sensors inside the robot, which is not the theoretical one from the CAD, right?
Right. So you have to do the URDF. You have to publish static TFs to say how each robot deviates, so that when the robot goes, an easy way to test, one thing that you can test to see if you're okay, like a sanity check. You go in a straight line along the wall, and you will see if the laser is rotated slightly or something, then you will see sort of snaking or all kind of. So that's another algorithm. We've developed proprietary path planning, so constraint-based path planning. So we have a very nice user interface where you define constraints, and then there is this very elaborate path planner that resolves for those constraints, and so like Google Maps and Waze, they constantly update and look for an optimal path. So there is global optimization and egotistic optimization, but you need to constantly, if suddenly that corridor is blocked, you don't want the robot to go there, you have to calculate an optimization. But if everybody goes the other way, then you will block there. So those are things that we felt were more proprietary and bring value to when you deploy large fleets, and so we didn't put them in the open source.
Okay. Then so just to clarify, then we have the Flow, which is the community edition, and the other one is the proprietary. Commercial edition, exactly. And then those algorithms that you explain, as well as the fleet management features, they are in the commercial version available. Right. But the whole functionality about creating programs, launching them, debugging them, state machine, editors, integration with simulator, creating your own blocks, right? Also, the whole thing is included into the how did you call it?
The community edition, open source.
Okay, but I wanted to use the name that you mentioned at the beginning.
Available.
Source available, exactly, which is the community edition. Okay, great. That is clear. And then, So I think that we talk all. So I had a set of questions to ask you about the different functionalities and things, but we already explained all those the points. I think that
I mean, you can look since you can edit it later. You can ask and then cut and paste.
No. This is the good thing because it goes. That's the beauty of the podcast, that it goes naturally, because otherwise we are doing this like robots, and I don't that's not my style for listening to a podcast. Question, answer. So this is a discussion, and I enjoy it very much, listening to you and also intervening when I think it's something is not clear for me or for the audience. So that's very good. Very good. No problem at all. And then I was just checking on my questions. If something missing on my questions that you didn't answer, and now I cannot think of. Because I wanted to ask you about the current limitations of MOV.AI, but we can consider that this question is also being answered because you explained that it's at present is not working, for example, for C++. Right?
So in terms of limitations, we're working in Python. The Move node, the editable node that we provide with VS Code on the browser, is a Python environment for now. That's one thing. So, but typically, if you want to work in C++, it's because you want extra performance, and so go ahead and do it in the standard
way
ROS environment, compile it, and then just add the block or the metadata associated, all your inputs and outputs and configuration parameters. Add them to the arsenal of blocks that then people can drag into the thing, and then it will magically run your executable.
Exactly. That would be the strategy. Yeah.
Another thing, limitation, I would say, something that is emerged over the years is that TCP is a bad thing in bad Wi-Fi. So anything TCP in fleet of robots running over wireless networks in factories where everything is a Faraday cage, and behind every corner there might be a dead spot of Wi-Fi. So TCP has this kind of state machine in the kernel, and it doesn't expose at the user level the reason why things are stuck. So things are stuck. There is all this sin and act going on, and it's like a lot of hidden agenda in TCP in order to do this reliable transportation. But it doesn't tell you if the problem is that you're roaming between access points, or your server is dead, or you're dead or something. So the problem is that creates delays and hiccups, and sometimes the robots get stuck because they are waiting for confirmation from a server. So you have that a lot, in centralized control. So we are now exploring decentralized control, meaning that the easiest example is blockchain. It's not that we're using blockchain, but blockchain is, in the sense, decentralized. So rather than asking the mutex permission to access the elevator, you have a consensus. You ask, you want to get 51% of the population to say okay. That's not necessarily that, but it's a whole world. There's a whole world of kind of decentralized control, and so we're exploring that. And so these are two things. One is decentralized control. The other one is UDP. So UDP means there is no hidden state machine in the Linux kernel. The state is managed at user level. So DDS does that. We use 0MQ for historical reason, but similar concept. If you want reliable transportation, you can do it. You don't have to use TCP. There are stacks, and then you get more visibility into why things are going wrong, or the kind of latency that you're getting. And so a lot of the industrial world with wireless networks has moved away from TCP. So we were using Redis as a central kind of controller, and that it works okay, but we see that it's going into kind of bottlenecks. At some point, there are these issues of scaling. So moving, that's another thing, and so we are moving out of that and into kind of more decentralized swarm, whatever you want to call it, but it's more robust and to scale to really thousands of robots. That's the objective.
Okay. And then, so a couple more of questions before we finish. So you kind of answer a little bit this one, but so what are the secret plans of the future for Flow? You mentioned those two right now about the limitations, but any other thing that you can tell
secret
us?
Secret plans
Yes.
for Flow. There are
something spicy.
I think Flow is perfect.
Okay.
No, I mean there are more and more deep into the container features. So meaning that when you run a containerized process, you can actually define for cybersecurity, for people who are cybersecurity conscious, when you run a process containerized, you can really go deep into what is allowed and not allowed. For example, open ports, that's a starting point, but you can actually limit the memory. So if a process has a typical footprint of a memory, you can kind of say, okay, I'm limiting your memory to that much. And if you go beyond, you get an OOM or it might kill the process or something, or you get notified that something is wrong. So more of that is going to be exposed in terms of how to run the containerized process. And then eventually what I'm hoping is that we will support other forms of containerization like snaps, which is great. You know, we spoke a lot with the Ubuntu guys and Podman, which is like Docker, but Red Hat. So I think right now we're with Docker. It's the popular kid, but it's not the only game in time, and eventually we'll probably support other containerized nodes.
Systems. So, okay, and just to let you know that we are about to launch a course in collaboration with Canonical about creating how to create snaps. So how to create ROS applications in snaps.
Right.
And well, actually, the people that is listening this episode, the course is already been released when you listen to this episode, but now that we are recording, it's still not available. So this is a premiere, is a secret plan of the construct that you know. Yeah,
that's great. No, I love snaps, and we selected to work with Docker because we just had more experience with it for now, and you cannot spread too far, with limited resources.
Mm. Okay, great. Then final question.
Yeah.
So then what is your opinion about the acquisition of the open source robotics corporation by Intrinsic? Because this is the hot topic this year, and still is going to be for a few months, I suppose. So what is your opinion about?
So I think overall it's good, okay? But let me explain my point of view. So they are within Intrinsic, but according to what was published, they are still committed to supporting, the ROS2 and the and a couple of more, and the ignition and the fleet management, and so I don't think that will go away. I think knowing some of the people there, I think they're very committed. It's not about, they're not doing it because of money necessarily, or I think they're really committed to the cause and to creating this open source framework that caters to robotic research and promoting this robot intelligence and robot collaboration. And so I don't think that is going to stop. So it's overall positive. And if they do decide to go into specific verticals, like for example, the fleet management is a specific vertical. But I think it just sets the bar higher. NAV2 is great. It wasn't there before, and it works really well. And everybody now has to do better than NAV2 or better than RMF if they want to sell it, right? Yeah. So I think overall it's positive. I think people who have there are some people that were really concerned, but I like the way that the OSRF team handled it, and they are regularly talking about things and answering every question. So it's the ROS is a great community. It's a tricky business because most of the participants are commercial, are net takers, right? The contributors are not many, but overall it's a nice community and super clever people, doing really sophisticated stuff. So I think it will continue. And if something happens with Intrinsic, I'm sure that ROS will continue in one way or another.
Yeah. In any case, that is going to demonstrate the strength of the community, right?
Yeah, exactly.
We did another podcast last week where we dedicated 1 whole hour to analyze this and to discuss it. So just in case that, and also to clarify, because I was talking to many people, many ROS developers there, and there was a lot of confusion about this subject. That is why I'm asking you also as an expert to know your opinion about it. But then we did this podcast where we were analyzing everything and discussing what it means and what does mean and what doesn't mean, and the different parts of the open robotics that still many people we didn't understand correctly. So we analyzed it and understood. Just in case that you are interested to.
And the conclusion was?
Yeah, the conclusion was that so that Google did not acquire ROS. That because that was the general opinion, among at least with the people that I talked to, and also that I'm not going to tell you because you have to listen to that podcast. I will put a link beneath on the show notes, and so you and the audience have to listen to that podcast. It was a discussion between 3 people. Okay, so
Great.
that's it for today. Thank you very much, Limor, for your explanations and a lot of good ideas and vision that you have shared here with us today. Yeah. Thank you very much.
Thank you for the opportunity to participate. I love the podcast, and everybody who wants to learn ROS, there is only one place to go.
Thank you very much. Thank you very much. Really, really appreciate it. And so you have listened to Limor, so that's the very, very good podcast. And please, if you like it, tell me something. Give me some feedback. I actually received 1 feedback. And I forgot to write down the name now, so I'm doing this wrong. Okay, so if you like it, give me some feedback, please. And that is all for today. And let's meet again next week with a new lesson from the expert. And until then, keep pushing your ROS learning.